Welcome to lecture series on graph data structure. In today's lecture series, we will discuss about topological sort. So before going into topological sort, let us have a quick recap on what we have discussed earlier. So in the earlier lecture, we have discussed about graph terminologies, how the graphs are represented, types of graphs, and graph traversal techniques. And now consider the following problem statement. So every day, students will have a lot of activities to do. So these activities includes getting up from the bed, taking baths, studying, eating, and many more. So achieving all these activities with the stipulated time and with the right optimization is indeed a difficult task. Now, to accomplish all these student activities, what algorithm do you think can be used? Now consider this empathize part. So this empathize includes how do we order the task based on the dependencies. So everything is done in an organized way. So imagine if you can't wear the shoes before the socks. How do we model such constraint? And what happens if the task has dependency over each other in a loop? And why a cycle breaks the ordering? So these are the things that you have to empathize before understanding what topological sort is all about. Now let us define what is topological sorting. It is linear order of vertices in a directed acyclic graph so that there is an edge for every vertex u from u before v. So this topological sorting is possible only if the given graph is directed acyclic graph. If there are cycles, topological sort cannot be done. So for a given graph, you can have more than one topological order. Now let us see how to calculate the topological order for a given vertex. First step is to calculate the in-degree of all the vertices. So what is in-degree? It is the number of incoming edges towards a particular vertex. So your first step is to calculate in-degree for all the vertices. Next, you have to find a vertex whose in-degree is 0 and that particular vertex has to be printed in the topological order. So that will be the first vertex in the topological order. So remove that vertex and its outgoing edges from the graph. After removing that vertex and outgoing edge, update the in-degree for the remaining vertex and repeat the steps 2 and 4, 2, 3 and 4 again. At last, if all the vertices are removed, the final order will be the topological order for the given graph. For example, in a graph, if you do not find any vertex with an in-degree 0, which means the given graph has a cycle and topological ordering is not possible. So this is an example of topological ordering for a graph. So now look at this example. For this graph, the topological order is 1, 2, 5, 4, 3, 6, and 7. This is one order for this particular graph. So likewise, you can have more than one topological order for a given graph. Here is a challenge for you to explore. So how do you handle dynamic graphs when there is dependencies? This is one challenge. Next challenge is, do you think neural networks will help with incomplete graph? And if there are cycles in a graph, and if it is detected earlier, how could you design a system to handle those cycles? So these are all some of the challenges for you to explore. So now let us summarize what we have seen in this today's lecture. So yeah, previously we did have a recall of the concepts we have discussed earlier, and we had a pretty good understanding of what topological sorting is about with the help of student example. So this topological sorting is only possible for a directed acyclic graph. When we are discussing about topological sorting, we have discussed key concepts like in-degrees and the various application of topological sorting is it is used in course scheduling, building system, and many more. And Kahn's algorithm, which is based on breadth first approach and DFS based approach, can be used for performing topological sort on a given graph. So this is an assessment. So find the topological order for this particular graph. Let us verify it in the next class. Hope you understood today's lecture. These are some of the references that will help you with the better understanding. And thanks for watching. In the next video, we will discuss about some other important topic on graph data structure.